easiest 4 marks. The way that probability works, as she wants 2 counters, therefore you must do your first pick followed by your second pick. You can't just pick 2 things in one go. As she's taking 2 counters in the bag, therefore we know it's without replacement. Therefore the probability on the first pick and the second pick is going to change. For her first pick, she's only got 2 different colour counters. She'll only get a green or a blue. So my first pick, I'm going to have 2 branches. Therefore, the probability of Rhea getting a green counter on her first pick, well, how many green counters were there to start with? There were 7 in total. So it's going to be 7 chances of being successful. So 7 on the top, out of on the bottom, divided by, there was 9 counters. So the chance of getting a green will be 7 out of 9. The other choice was blue. Well, the chance of getting a blue counter on our first pick, how many blue counters? There was 2 blue counters to start with. So the chance of being successful is going to be 2. And it's going to be out of, again, the top number of counters. In this case, there was 9 counters to start with. If Rhea got a green counter on her first pick, for her second pick, she could still get a green counter or a blue counter. Likewise, if Rhea got a blue counter on her first pick, on her second pick, she could still get a green counter or a blue counter. As it's without replacement, our probabilities on our second pick will all be out of 1 less. In this case, they'll all be out of 8. Because to start with, there was 9 counters in the bag. Whether she got green or blue, after the first pick, there's going to be 1 counter less. Now, following the first branch, this is the probability that Rhea got green on her first pick, was 7 out of 9. So the chance of getting green on her second pick, well, there's only 7 green to start with. As she got green, there'll also be 1 green less in the bag. So there was only 7 to start with, so we subtract 1 also from the numerator. So 7 subtract 1, there's now only 6 chance of getting green. So 6 chances of being successful out of, there's only 8 counters because there's still 1 counter gone, which is the green. If she got green on her first pick, the probability of getting blue on her second pick, well, blue hasn't changed. So there's still 2 blue counters in the bag. So that's going on top. So there's 2 chances of being successful, but it's out of, again, 8. Because there's still 1 counter gone from the bag, which is the green. If she got blue on her first pick, the probability of getting green on her second pick, well, green hasn't changed yet. So how many green counters? There's still 7 green counters in the bag. But again, it's out of 8, because there's still 1 counter gone, which is the blue counter. If she got blue the first pick, the probability of getting blue again on her second pick, well, there's only 2 blue to start with. And as she got blue, the numerator will also drop by 1. So there was only 2 blue to start with. There's now only 1. And again, it's out of 8, because there's still 1 counter gone from the bag, which is the blue counter. As we're asked to work out the probability that Rhea takes 1 counter of each colour, we're looking at our tree diagram. If she got green on her first pick, she'd have to get blue on her second pick. And if you go along a branch, you multiply the probabilities. Or she could get blue on her first pick, followed by green on her second pick. Again, if you go along a branch in probability, you multiply. When multiplying fractions, I just multiply the tops and multiply the bottom separately. So 7 times 2 on the top gives us 14. And the bottom 9 times 8 gives us 72. Again, we're multiplying fractions times the tops times the bottom. 7 times 2 gives 14 on the top. And 9 times 8 gives us 72. As there was 2 ways of getting 1 counter of each colour, I could either get green followed by blue, or I could get blue followed by green. Well, or in probability means add, and it's going to add my 2 fractions together. When adding fractions, I must have the same denominator. As I've already got the same denominator, they're both out of 72. Just keep the denominator the same, out of 72, and just simply add the numerators, add the 2 top numbers. And 14 add 14 gives us 28.